All right, welcome. My name is Dr. Robyn MacKillop, and I run Get That GED, and you can find it at getthatged.com, and there's a Facebook group. I'm also the administrator of GED Study Group. That's not my group, I'm just one of the administrators on it. But my group is Get That GED, and I help people get their GEDs as fast as they want to get them, all subjects. And today we're going to work on math because math is a big deal. And we're going to do slope and the various equations that help you find slope, Y-intercept, everything you need for graphing lines. All right, any questions before we get started? Okay, let's do this. One of the things too is if you don't already have a TI-30 XS, see if you can get your hands on. Perfect. Yes, Ira's got it. This you can actually take into a testing center. I do not think you can use it if you test online at home. I think they make you use the one on the computer. But if you are going to go to a testing center, take it with you and use it. So much easier to have it in your hand than to try to manipulate the one on screen. And we'll probably use it a little bit tonight, not a whole lot, but a little bit. I'm certain I'll run into something, but I just don't want to calculate in my head. Okay, I'm going to switch cameras. Maybe. What is it doing? It's not going to let me switch cameras. Hold on, there it goes. Whew. There we go. Okay, so we're going to begin with finding the slope when we've got two ordered pairs. And the way that this question will likely be written is it'll say, find the slope of each line that passes through two given points. And this is what you'll see. This is what they'll give you. And they'll want you to figure out how to graph a line with those. And I won't get ahead of myself because I could very easily do that and lead you down a tangent. So I'll try to stay in order. So when we've got two sets of ordered pairs or two sets of coordinates, this is the formula we're going to use. This is how you find a slope given two sets of coordinates. And every coordinate you ever see is always, the first number is X, the second number is Y. That will never change. It will always be X, Y. Always, always. So when we have two sets, we're going to start with the first set. We're going to say it's X1, Y1, X2, Y2. Now, all we have to do is plug these into this formula. So we're going to start with Y1 on the top, because this is X2 minus Y1 over, Y2 minus Y1 over X2 minus X1. We're just going to plug these in. I'm going to start with Y1 is 5. Y2 is 9, so that's going to be 9 minus 5 over X2 is 6 minus X1 is 1. Then you just do the calculation. 9 minus 5 is 4. 6 minus 1 is 5. That is your slope. It looks like a fraction. Most of the time, do not treat it like a fraction, because really it is rise over run. And that's what you figured out from these two sets of coordinates. You figured out the rise over the run, and that is also Y over X, not coordinates, but the line Y on a graph over X. So try not to treat these like fractions. Sometimes you just feel compelled to reduce them, you don't have to. You can leave them just as they are. And you never want to turn them into mixed fractions because that will just mess everything up. All right, let's do a couple more of these and then we'll move on to the next. Because there's a lot. There's a lot you get to do with slope and y-intercept and all of that. All right, so let's try coordinates. Let's get some negatives in here. Let's do -2 and 1. And then we've got -3 and +3. And again, always x, y. First set, we're going to make 1. Second set, we're just going to make it x2, y2. And again, our slope formula is y2 minus y1 over x2 minus x1. I usually say do not bother memorizing formulas because they will be on the GED formula sheet. However, this one you'll end up memorizing because you do it so often. You'll just commit it to memory because you do it all the time in graphing. All right, so let's plug these in. We're looking for y2, that is 3, minus y1 is it's 1. Wasn't looking where I should have been. 3 minus 1 over x2 is -3 minus x1 is -2. All right, that's a little messy. We have 2 negatives in a row. What happens when we have negatives lined up like that? They combine into a plus sign. So this is actually -3 plus 2. It's a little bit easier. So anytime you've got 2 negative signs right in a row, turn them into a plus. And now we're going to do the arithmetic. 3 minus 1 is 2. -3 plus 2 is -1. Keep your negative. If the top or the bottom is negative, leave it because you need that when you graph. And technically, it does not matter if it turned out that the top number was the negative and the bottom was the positive. It doesn't matter because they're 2 different things, and the negative is important when you actually put it on a graph. So let it be and don't worry about it. It is what it is. Now I'm going to try graphing this. And because they give us the coordinates, it's actually a little bit easier to graph because we just have to put the dots in. So the first coordinate is -2 and 1, which means we're going to go to -2 on the x line and then up 1 because the 1 is positive. So -2 up 1. Now we know what the slope is. The slope is 2 over -1, which is rise over run. So +2 over -1. That means if we start at the coordinate we put in, we're going to go +2, that's up because that's the rise. It follows the y line. 1, 2, and then we're going to go to the left 1 point, 1 space right here. And we go left because it was a -1. Does that make sense? Up 2, because that's positive on the y line. Then we're going to go over to the left on the x line, -1. And we can keep doing that. We can do it either direction and we can just keep going. 1, 2, positive, over to the left, -1. And we start to build a line. The thing is, you can draw a line with 2 coordinates. You do not need to find more than 2 because if you have a straight edge, this is the worst part. You're going to connect that line with just 2 points. And now you can check your slope, because we said slope for this one was 2, -1. And the way to check it, if you don't want to deal with the numbers on the sides, count the boxes on the grid. So we're starting with this coordinate right here. Our slope was 2 over -1, which is rise over run. The rise in between the two coordinates is 2 spaces, 1, 2, that matches. The horizontal spacing between the two coordinates is 1, and it happens to go to the left, so it's -1. You can actually just count boxes to check to see if the slope works with your line, and it does. 1, 2 over 1. Look at that. You can also do it with the numbers. The difference between where that coordinate is here, 1, and the next coordinate 3. Well, the difference between 3 and 1 is 2. And then on the X line, the difference between -2 and -3 is -1. It's kind of nice when it all goes together, when it matches. You know you're on the right track when you can look at it a couple different ways. So let's go to the next style of slope problems. And that's going to be, this one we're going to use the Y-Intercept Form, or Slope-Intercept Form is what it's called magically. So this is, let me push this up a little bit. This one, Y equals mx plus b. This is the slope-intercept form. Intercept form. And again, this is probably one you're going to end up memorizing just because you'll do it so often. But again, don't commit it to memory on purpose. It's going to be in your formula sheet. And just know that it's slope-intercept form. That's how it'll be labeled on the sheet that they give you. And it's what you use when you get a direction that says, change the following linear equation from standard form to slope-intercept form. And all they're going to make you do is make your equation match that. So let's start with this equation. Let's start with y plus 3x equals 7. So this is a typical equation. We dealt with these a lot when we're doing linear equations and isolating one of the variables. And you can see the difference. This is y plus, this is y equals. So we have to turn this one to look like this one, which means we change it. We start with y equals. We can do this to a problem as long as the number with the x goes opposite of what it was originally. It's positive up here. Down here, it's going to be negative. And as long as you make that switch, you can change, you can move that equal sign. And then again, we're going to keep the plus, and the 7 stays the same. So the only number you are altering is the one with the x. So it doesn't matter what y is. It could be 500,000 y, and this could be 1652. These stay the same. It's this number with the x that you're going to convert. If it's positive in your original equation, it will be negative in your slope-intercept form. If it's negative in your original equation, it's going to be positive in your slope-intercept form. So this looks pretty good. And all's we really, I mean, we've done what they've asked us to do. They asked us to change that linear equation into slope-intercept form. And they do ask us to graph the line in this particular thing that I'm using. And I will graph the line. I'm not sure that you will have to do that on the test. I'm thinking if you have to put anything onto a graph, you'll have to put coordinates in because it's pretty hard to draw a line on the computer. And I don't think it has the mechanism for you to start in one place and do a nice straight line up to another. You may have to plop coordinates in, but I don't think you'll have to graph any lines. But I'm going to show you how to graph the line anyway, given that you have turned this equation into slope-intercept form. So I think, oh, I missed something here. The M, I'm going to move that down so it's easier to see. M times X plus B. M is your slope. B is your Y-intercept. And the Y-intercept is where your line crosses the Y-axis. So that's all this is, which in this case is 7. So let's just start with the Y-intercept. So we're going to put a coordinate at +7 on Y. So right here. And our slope is -3 over 1. If you have a whole number for your slope, you just put a 1 underneath it. And that means you're going to go to the right 1 space every time you count boxes. So we've got this coordinate right here. And our slope is -3 over 1. Rise. And I keep saying this just so you remember, because you'll see this. -3 means we go down. So 1, 2, 3 spaces. And the 1 means we're going to go to the right on Y. Or excuse me, on X. What did I just say? Down 3 on Y, 1 over to the right on X. And that's our -3 rise, goes down the Y. +1 on run goes to the right. So X line, Y line, rise, run. And we can do another set. We don't have to because we can actually graph that line the way it is. Because we only need 2 coordinates to graph a line. We just line up the center of those points. And that's a nice thing about having graphing paper or a grid. And just like that, we graphed this line. Cool, huh? It doesn't seem quite so daunting. I mean, some of the instructions on the test are aggravating because they're not really clear. And the thing is, you will know what to do. The hardest part will be figuring out exactly what they're asking you to do. You'll know how to do it. If they were clear, you could do it. They're not clear. It's kind of a strategy to not be clear. All right. Should I do another one of those? Or is that easy? Let me do one. Let me do one more. I know which one I want to do. I need a negative. Yeah, that one right there. So on this one, the equation is going to be -2x plus 5y equals -5. And we're going to turn this problem into slope-intercept form, which is making it look like this. And what's interesting here is they flipped the X and the Y, and the Y has a number in front of it. That doesn't change anything. We're still going to make it look just like that. We're going to start with our Y. So 5y equals, so far so good. And still, once we get here, because we flipped the equal sign, we changed the equal sign and the plus sign, the number with the X has to be the opposite here than it is here. So this is -2, which means this one is going to be +2. And then we've got plus -5, and we don't have to change that 5 at all. Another way to write that is you can get rid of the plus sign by saying 5y equals 2x minus 5. These are the exact same equation. You just do what makes the most sense to you. If you like that plus sign with the negative, do it that way. If you just like the -5, do it that way. Same exact thing. So our 2, oh wait, we're not done here, sorry. We've got this extra 5. We didn't have anything up here to deal with. And anytime you have a variable by itself, it's the same as 1y, which is why we can put that 1 under the 3. But here we've got this 5. We have to get rid of that because we need the we need the y isolated. So we're going to divide out the 5. And when we do that, these two cancel, and this is just y. Then we have to divide out 5 here. However, this is your slope. Let it stay as it is. You don't want to try to divide the 2 by 5. Let that be your slope, 2 over 5. And then we've got that -5. We also have to divide out 5 because what we do on one side, we have to do on the other. And -5 divided by 5 is -1. So we're going to keep the slope as is. 2 over 5 times x minus 1. This is our slope-intercept form. This was our original equation, or this was our original, yeah, this one, original equation. And then we can graph that. So our y-intercept is -1. That's where we're going to start. Our slope is 2 over 5. So let's start here, -1. And our slope was 2 over 5, both positive. So we're going to go up to the right 5. 1, 2 on y, go up. 1, 2, 3, 4, 5 on x. That's your rise over run. And again, we only need 2 coordinates. We don't have to, you can do as many coordinates as you like. If you want to keep going and build a whole line with coordinates, you can, but you don't have to. Because as soon as you have 2, just use a straight edge. Make sure it crosses right in the middle of those grid boxes. And then you can check your work. Between this coordinate and this one, we've got 2 spaces on the y line. That's your rise. And between, on the horizontal, we've got 1, 2, 3, 4, 5. 5 spaces. That's your run. Perfect. You've done it. You've graphed a line. You have turned an equation into slope-intercept form. You've turned a second equation into slope-intercept form, and you graph the line. All done with that. We like it. Let's do a couple more different. Okay, so up next, we are going to deal with finding the equation of a line in slope-intercept form where they give us a slope and it passes through 2 points. I probably should write that out because that's a lot. So we're going to find the equation. Oh, I'm off the outside of your view. Find the equation in slope-intercept form. That passes through it's a lot of writing. I don't realize how long it takes until I'm making you wait for me. Passes through, let's say 3 and 1, slope is 4. This may be a instruction you see on the test. Find the equation in slope-intercept, that looks like interrupt, is actually intercept form that passes through the coordinates 3 and 1. Slope equals 4. So in this case, we've got some information already. We know that slope is 4. We know the line's going through 3, 1. What we do with this one, we need to find B. We're still going to use the equation we just got done using, the slope-intercept. Y equals slope M times X plus B, B being the Y-intercept. Y-intercept, M is your slope. And all coordinates again, first one is X, second one is Y. Look at that, we've got 1, 2, 3 pieces already of this equation. We're just gonna write it up. We're gonna plug these into this. So Y is 1. 1 equals, M is slope, that's 4, times X, which is 3, plus B. Now this is looking a lot like the linear equations we do before graphing. We just need to get all the numbers to one side of the equal sign so we can determine what the variable is, what the B is. So we'll do the calculation here. 1 equals 4 times 3 is 12 plus B. And I know that looks like a 6. I'm so sorry. They should never use B's, S's, or L's as variables. They look like numbers. And here, to get all the numbers to one side, we have to remove that 12. So we're going to take away 12 here. And whatever we do on one side, we have to do on the other. So we're going to take away 12 here. 1 minus 12 is negative 11 equals B. Just like that, we filled out our slope or our intercept form. And that means we have a slope of 4 and a y-intercept of negative 11. Pretty interesting, huh? These are not too bad. They're just different ways of finding the exact same thing. We started with 2 sets of coordinates and found the slope by using the coordinate form, y2 minus y1 over x2 minus x1. Then we found the slope from an equation by turning a regular equation into the slope-intercept format. And here they've given us a set of coordinates and the slope, and we still can graph the line because we have all the information. That's all the information you really need for graphing. And we found the y-intercept. So a lot of different styles of asking you to do pretty much the same thing, and they might give you slightly different information. So it's doable. And as you become more comfortable, if you're not already comfortable with this, you just do some practice and you'll have it. Because once you've got the process, it doesn't really change. And so whatever they throw at you, you'll be like, you know what? I know how to find the slope. I can find it if they give me 2 coordinates. I can find it if they give me 1 coordinate. I can find it if they bury it under mountains of text. I can find it. And just keep telling yourself that because you can. And that'll get you through the test. There's one other style. Nope, that just goes back to the double coordinates. So we don't need to do that because we already did that. All right, let me see what else I can give you. Well, we're burning right through this. I take much longer when I'm teaching this privately. All right, the other thing we can do, sometimes we'll have to find an equation of a line in point slope form, which is one more formula. It's not a hugely different formula, which is good. But it is another formula for finding slope. It gets old having all these formulas because that's when people start to get messed up on the test because they're already stressed out and you're trying to keep things straight. But remember, all of these formulas are on the formula sheet. Okay, so in this case, we're looking at a formula that looks something like this. And it's similar to what we've done. It's not quite the same, but it's very similar. Y minus Y1, so that would be coordinates, of course, equals the slope. And again, I think slope is M because S looks like a 5. That would be really confusing. I mean, it's bad enough they give me a B because my B's look like 6s. And that would be slope times X minus X1. And if they want you to find something using, or they want you to find the equation of a line in this format, they have to give you some information to do that. Often they'll give you a set of ordered pairs, 1, 3, and they'll give you the slope. And let's say slope is 4. And again, we're going to do kind of what we did on the last one, because I think these are the exact same numbers I used on the last example. And all we're going to do is fill in what we know. So this is the same as what we were doing before, X1, Y1. And that will help you know which ones you substitute. So we've got Y. We don't have one for that yet. Minus Y1 is 3 equals slope is 4 times X minus X1. And that's a pretty hefty little equation they want us to deal with. So let's see if we can figure it out. Not much we can do with Y minus 3, that just stays the same. However, we have some calculating to do on this side because we have to get rid of the parentheses, which means we have to times 4 by the first number. 4 times X is 4X minus 4 times the second number is 4. And the next thing we can do is get the like over to one side. So the numbers over to one side, which means, and this is just going back to linear equations, we're going to get rid of this 3. So we're going to add 3 to this side because that zeroes it out on this side. Whatever we do on this side, we have to do over here. We're going to add 3 to that 4. Now it says Y equals, and tell me if I run off the page. I do that sometimes without realizing. 4X minus 1. So we just turned this information into slope-intercept form. Because slope, that's using point-intercept form. It's crazy. It's so many formulas, but they will ask you to do this stuff because giving you a jumble of things to do for the same type of problem, it's better for, and Pearson is the company that runs GED, they make more money. The more times they can mess you up, the more money they make. So remember, when you're feeling frustrated with it, you can beat Pearson. They're doing these things to mess with you. You can beat them. And the directions for this one was find an equation of a line in point slope form. That's your point slope form. That's what they gave us to use. That's the information they gave us to use. And it's just a slightly different formula than what we were using. And we just found the slope-intercept form of this, and we could graph the line right now. We know that the y-intercept is -1, and we know that the slope is 4/1. So we just jump over here, -1, slope is +4, 1, 2, 3, 4, +1, so it goes to the right. And there's our line. We just draw a line through that, and then we can even count the boxes to make sure we're on the right track. So it looks worse than it is. Once you've got the process down, it doesn't matter what they throw at you, you can do it. I think the biggest issue is when they bury the information in a story problem. That's a lot harder to see because it's not right out there where you can say, okay, well, I know what formula to use. Now you have to dig out the information, and that's never fun. But it's doable. You can and you will ace your test. I'm going to switch cameras back to me. All right, how was that? That was quick and dirty. And if you end up having any questions, just send me a message or ping me. I'm happy to give you some pointers and run you through some processes. Because the most important thing is that you are comfortable to sit for the test and to get through it. It's a long test. It's not as long as language arts, but it's a long test, and it asks you to know so much information in one sitting. It's appalling. It would take several years of high school to deliver that much information in one test. So it's pretty impressive when you guys sit down for it, take it, pass it. All right, well, I've run through the stuff I was going to run through, and we did it in 40 minutes. That's pretty good. And I am a GED teacher, and I'm here to help people. If you want one-on-one coaching and help, there is a fee for it, but you can talk to me and we can work it out. And other than that, I'll keep doing these, and I'll still keep answering questions in the group. And one way or another, we're going to get every one of you through. Just like that. You're all going to be grads. All right. Well, thanks for coming. And I'm going to run this again, same time tomorrow. I'm pretty much going to do the same thing. And so you're welcome to join again, or tell your friends, if you have friends who are working towards their GED, tell them to hop on. And I did record, so I can send it out to people. All right. Well, thank you so much for being here, and I will see you again. Have a great day.